Math, always giving us such headache, with all those numbers and formulas and more formulas. But we can always find a way out.
Hello, my name is Dulce and I'm going to explain you continuity. First of all, do you know what continuity is? In math, it's the rigorous formulation of the intuitive concept of a function that varies with no abrupt breaks or jumps. Did you get that? Well, if you didn't get that, just picture a graph that doesn't have any abrupt breaks or jumps. Now we can start, but we are not going to start with continuity. First, we need to do a little bit of background on graphs.
First, we have x squared. Remember, x squared has the shape of a U. Don't forget it. Up next, we have another x squared, only this time in a negative form. This is exactly the same, only the U shape is now facing down, like a sad face. When you have this form, you only have the value of the x-axis, so you will have a vertical line. When you have this form, you only have the value of the y-axis, so you will have an horizontal line. When you have the equation of the line, you will have a sloping line. When we have the absolute value of x, the shape of the graph will be like a V. When we have the absolute value of x, but with a negative sign outside, the shape will be again like a V, but the V will be facing down. When we have the square root of x, the graph will be like the half of the U shape. When we have the negative square root of x, again it's the half of the U shape, but to the opposite side. When we have x cubic, the graph will be like an S facing to the right. And when we have a negative x cubic, the graph will be like an S but facing to the left.
Now we can begin with continuity. In continuity, we have 3 rules. Rule number 1. Rule number 2. Rule number 3. Here are some examples.
On this example, we can see that this is not continuous because of rule number 1, because when the values approaches to 2, they are not the same, so the limit doesn't exist. On this next example, we can see that it is continuous by rule number 1, but not by rule number 2, because there is not an exactly value for y when it approaches to -1. On this example, we can see that it is continuous by rule number 2 and rule number 1, but it's not by rule number 3, because the limits are not the same of rule number 1 and rule number 2. Finally, this is continuous because rule number 1, 2, and 3 applies.
Thank you very much. I see you next time.